Hi guys, here's our second video, and today we're going to be talking about atomic and mass ratio and also percent composition. So let's go ahead and get started. All this stuff is really easy. Don't be thrown off by the fact that we're using numbers again. Let's talk about ratios first of all. And you all know what a ratio is. I mean, they use ratios all the time in sports. Baseball, they have, I think, strike and walk ratios for pitchers, and horse racing, of course, you have your odds, 20 to 1 or 1 to 1. And football, soccer, they all have them. This is just a ratio. A ratio, by definition, is just a way of showing a relationship between two quantities of something, actually two or more quantities of something. The most common way of stating the ratio is using the colon, which I show you here. And I am not going to write on this podcast. I like to write so that you can follow me, but we're looking into ways that I could do that a little bit better. So we use the colon when we're doing ratios. And again, read it as 8 to 1, 6 to 1, 20 to 1. If you have more than two elements in a compound, now obviously we're doing this for chemistry, that means that you will have more than two numbers in your ratio. For example, 1 to 4 to 5 or whatever. By the way, my voice seems to be going, so I apologize if I'm a little craggy. The ratios must always be in the order of the elements in the compounds. This is so important, okay? They must always be in the order of the elements in the compounds, and I'll show you this momentarily. There's two different types of ratios we're going to look at today. Both of them very easy. Atomic ratio is the first one, and all atomic ratio is looking at how many of each element are in the compound. So it's just those subscripts. Sometimes we like to divide both numbers by the smaller number to simplify, and we'll look at that. But it's just, that's all it is. Oh, what's that? That just popped up on my screen. There's another one. Kind of cute though, aren't they? It's hydrogen. Oh my goodness. And this is oxygen. It's 16 times more massive than hydrogen. How did I know that? Or I did know that. How did I know that? Gosh. Can you guess what compound we are? There's 2 hydrogen and 1 oxygen. I wonder. Let's get back to the atomic ratio. What is the atomic ratio of dihydrogen monoxide? Of course, water. The first, you know how I am with rules. I like to have rules for everything. The first rule is you have to write the formula down. And sometimes the formula is given, so you can skip this part, but sometimes it's not. Then you determine the relationship between the elements. In this case, we have 2 hydrogen to 1 oxygen. Notice the 2 goes first because it has to be in the order of the elements. And then to simplify, you would divide both numbers by the lowest number. And in this case, it would be a 2 to 1 ratio. And I mean, that's all it is. If you have a 1 in your ratio here in the relationship, then you're done. If you have a 1, you're done. All right, let's move on. Let's write the simplified atomic ratio of hydrogen peroxide. This is a substance that many of us have in our medicine chests at home. The first thing we're going to do is write the formula, easy, being as it's been given. Then determine the relationship between the 2 elements, and then simplify. We have H2O2. There's a 2 to 2 ratio here, hydrogen to oxygen. And then we come down here to simplify, we would divide both numbers by the lowest number, which is 2, and we would see that there's actually a 1-to-1 hydrogen to oxygen. Hydrogen must always come first, as you know. Hydrogen to oxygen ratio. That just means that in hydrogen peroxide, for every 1 hydrogen you have to have 1 oxygen. Okay? That takes us to mass ratio, the second type of ratio that we're going to look at. Mass ratio, again, is very easy, and you've learned a lot of the steps leading up to this when we did molecular mass and formula mass and molar mass. So, piece of cake. The mass ratio doesn't look at the number of atoms, it looks at the masses of the atoms, of the elements in the compound. You can simplify, sometimes you don't. Just depends on what you're doing with the information. Let's look at that rascal water and find its mass ratio. First thing you do, you write the formula, H2O. You determine the mass relationship, okay? This is, in this case, it'd be molecular mass. We have hydrogen, we have 1.01 AMUs times 2 equals 2. We're just rounding here. Oxygen, there's 1 oxygen times 16, gives us 16 AMUs. We have a mass ratio of 2 to 16. Now, we can simplify this by dividing both sides by 2, and we find that in a water molecule, the amount of oxygen by mass is 8 times greater than the amount of hydrogen. And again, why do you care? Well, later on you'll see why you care. But learning it step by step is the best way to go. Okay, we're going to do another one. What is the mass ratio of carbon dioxide? Why don't you pause here and do this, and then we'll come back and finish it. First step, write the formula. Second step, determine the relationship. Here we're looking at CO2, carbon, 1 times 12 equals 12, oxygen, 16 times 2 equals 32, has a mass ratio of 12 to 32. Now, if I wanted to simplify this, I would divide both sides by 12, and we would see that there is a 1 to 2.67 mass ratio of carbon to oxygen in carbon dioxide. Okay? Very simple. And this is just all the stuff that we've been doing. We're just using it, taking it one step further now. That means that in this molecule, the total oxygen is 2.67 times more massive than the carbon. Okay. Pause and do these, and then we'll come back and talk about them in a minute. Let's look at the atomic ratio of FeSO4. I'm just going to give you the answers here. Atomic ratio 1 to 1 to 4. What is the mass ratio of iron sulfate? You look at the mass of the iron, the sulfur, and the oxygen. It's 56 to 32 to 64. That's just from calculating the formula mass. And you can simplify that to 1.75 to 1 to 2. Notice I kept it in order by element, iron first, then the sulfur, then the oxygen. Atomic ratio of silicon dioxide, SiO2, it's obviously 1 to 2. Mass ratio for silicon dioxide, 28 to 32. Again, I just look at the periodic table, and I get the molecular mass for this. And you can simplify that to 1.14. Okay?